One of the really powerful parts about Tableau is the ability to bring disparate sources of information together into one visualization. And as it turns out, there are some design decisions we have to make around that in terms of most effectively and most efficiently communicating that story to users. So let's do one example where we can see the differences between having two separate plots, having one plot with a combined axis and one plot with dual axes, and when we would use these various solutions, one versus the other. So let's go through, and we're going to deal with everything just in one sheet to make everything nice and easier. So we're going to be doing sales. Our independent variable here is going to be sales date, so we're going to drag that pill to our columns, and we're going to then compare. Let's do sales versus discount. So for instance, as a business perspective, or as a business question, an interesting question is, are we actually lowering our discount rates when our sales go up? I would expect that. As a manager, I would kind of hope that that's true. There's no reason to be offering discounts when sales are robust, or at least that's what you might think. But who knows? Let's see how things are going. So let's do the count of the sales for our rows. And then I also want discount here. And notice that the way that the sheet is organized, the count of the sales is really like the actual number of sales. But we don't want the sum of the discount. We actually want the average discount. So we're going to have to go down here and change the aggregation from sum to average. Okay, so that's just a small thing. But again, like, you don't necessarily want all the discounts added up. You want the average discount across all the orders that you supplied. Whereas because each row is a sale, you really do want the count of the number of sales in order to get an idea of how much you're actually selling in a given period. So right now this is aggregated by year for our date. You could do it by anything, but let's just do it by month. And so now we have two pieces here. So we can see that as sales goes up, the average discount rate goes down. But then there are cases where, for instance, around Christmas, where we have sales that have gone up and discount rates that have gone up. And so that, again, this is a place to start a conversation with your business team about what you're doing as far as your discounting strategy. But this is all the data you would need, or some of the data you would need, in order to make those decisions actionable. Our goal then is to make this as clear as possible in terms of it's communicating an effective message. And I'm not sure that having these two things on separate graphs is the best way. For instance, like the data to ink ratio here is relatively low. We have a lot of space in just these two time series. So maybe if we could get them on the same plot in a way that made sense, then we could actually have a higher data to ink ratio, a more punchy, compelling story, and one that users more easily engaged with. So to get these things on the same axis, let's take, I'm going to hover over the vertical axis here, and we see this little triangle. If I drag this up here, notice that I get this little it's like two rulers or two measuring sticks next to each other. And basically what that's going to say is we're going to combine the axes of these two things here. So notice that the vertical axis is now called value, because it's describing like who knows what. And in particular, this value could be either the average discount value or the count of sales value, one green and one orange. But notice that this is not really ideal, at least for me, right? Because the scale on which discount plays out is so much smaller than the scale at which the total number of sales plays out. I can't see any of the variation in discount if I'm looking at the scale of sales. So let me just say that again. The scale at which sales plays out, the number at which sales is often seen is on the order of thousands, whereas in the discount it has to be less than 1 because it's in a percent. So I can't see any of the variability in discount if I'm looking at the variability of sales and I'm forcing these things to be on the same axis. So let me just undo with Control Z, and let's try a different approach. So rather than having the combined axis where I'm forcing that axis to have the same units, whether it's for sales or for discount, let's drag it to the right hand side, and notice I just get one ruler this time. This is a dual axis. So notice that on the right hand side I have sales, and this is my sales measurement. On the the left hand side I have sales. On the right hand side I have discount. And so this is actually a different scale than this one. And the hard part here is the user has to know which one to look for and say, oh, like, okay, average discount, that's this scale, and now we're talking about like, oh, this is 10%. And okay, we're on this side, we're talking about sales, and here, okay, this is sales of 5,000. So it does introduce some complications, but one thing that it does really, really nicely is now everything's on one graph. We have a higher data to ink ratio, and we can actually see that maybe these things are counter-cyclical in some places and actually positively correlated in other places. So the distinction here, just to be clear, is that we can have separate plots that happen to have a shared axis, like a shared x-axis in terms of date. We can have the same plot where the two traces are sharing their y-axis. This is a combined axis plot. Or we can actually have a dual axis plot where the plots are on the same graph, but they have independent y-axes so that the scales, if they're very different, can be really easily seen. So for instance, on the scale here we have thousands, and the scale here we have like 0.1 is our common, like our fundamental unit. And so these are just fundamentally different. So in this case, separating these things out doesn't seem super appropriate. Using a combined axis does not at all seem appropriate because the scales are so different, but a dual axis seems to work pretty well. Obviously, in different circumstances, your choice about whether you use separate plots, a combined axis, or dual axes are going to change. But hopefully this gives you all the tools you need to investigate which one of those options might be better for you in a particular situation.